water is the killer when it comes to hurricanes and tropical storms. But you've done some research and you've found something else that's really causing problems, correct?
That's right. Hurricanes, tropical storms are some of the most destructive, extreme events, climate events that we have. Like you said, the rain, the wind, the storm surges. In the moment, they cause widespread catastrophic damage. But what we looked at is, well, what happens in the aftermath of these storms when, after their passage, systems are affected, energy systems are affected, infrastructure is affected. And so we looked at heat, and do these storms, are they associated with, a period after the storms that have elevated heat? And if so, what are the consequences of that? We didn't look at the consequences. We were just trying to find the heat patterns. Turns out that a lot of these tropical storms, they're heat pumps. They do bring warmer conditions in the aftermath. Some as high as close to 9 degrees Fahrenheit above what's sort of normal for that period of time. And what that means is, there's extreme heat conditions, can affect public health. Obviously, the energy grids are knocked out in some of the larger storms, and can be difficult to cool your houses if you have medications, for example, and you don't have a generator. That can cause some issues with medication. So we were thinking about the compound nature of extreme events that happen in succession, such as a hurricane followed by a warm period, and what that might mean for public health was sort of our lens.
So you found a pattern. Do you know why this is happening?
Yeah, we speculated on the reasons. This is really sort of novel research, and there hadn't been a lot of studies out there looking at the co-occurrence of heat and tropical cyclones. So we were just set out to characterize the patterns in space and in time. But some of the reasons that might relate to sort of elevated heat in the aftermath are just the cyclonic flow. The counterclockwise flow of the storms can actually entrain moist and warmer conditions from the south. If you're on sort of if you're on the eastern side of the storm, so the storm's duration and its sort of orientation to the point of interest matters here. But wind can entrain elevated moisture and temperatures. And just the pattern of subsistence of air descending and rising can relate to temperatures because they affect such things as cloud cover.
Did you see this at all in the 2022 season?
We did, actually. Now, our data that we analyzed was not 2022, but as it turns out, as we were publishing this paper, in the revision process, Hurricane Fiona struck Puerto Rico, and then two to 3 days later, the National Weather Service in Puerto Rico issued a heat advisory. So it was sort of confirmation that these elevated temperatures and hurricanes can co-occur. And we also found that in Puerto Rico sort of was the hotspot, perhaps because it's a larger island and you have these complicated land surface interactions. But in the past, temperatures following a hurricane were, like I said before, as much as 5°C or close to 9 degrees Fahrenheit above their sort of average for that period, and it crested into the range of borderline extremely dangerous conditions for heat in terms of the heat index, which is the sort of measure of heat that we were using.
So what's the goal with this information? What's the next step that you're going to do with it?
Well, our goal really was to bring attention, was to explore whether or not there was this compound hazard. Compound hazards are some of the most difficult for society to deal with because there's two or more of these extreme events that can cause different kinds of impacts. And like I said before, there isn't a lot of work on the co-occurrence of heat and hurricanes. And so, our goal was to explore whether or not there was a relationship. We found a relationship. We're bringing attention to it. We've got further research that's going to explore more of the dynamics associated with this. But really the goal is to make sure that people are aware of the possibility that, following the hurricane, all of the attention is going to be on the hurricane for obvious reasons. It's a very catastrophic event. And it can be the case that there are additional impacts related to heat. We don't want to divert the attention from the main thing, which is the impacts related to the tropical cyclone and hurricanes. But we do want to recognize that there are additional different kinds of impacts that may result sometimes. I mean, our research pointed out that while there was elevated temperature after all of the storms that we analyzed, and we analyzed 205 separate city storm events, all of them had elevated temperatures, but not all of them had really high elevated temperatures. So, this is a case where conditions are pretty nuanced, and there is a possibility, and we can forecast those. We're not forecasters, but there's wonderful tools of forecasting. It's some of the greatest inventions that we've had in science, at least in meteorology over the last 50 years. And so we can anticipate these elevated conditions. So goals: bringing awareness, making sure that people keep their eye on the main impacts, but are actually aware that there's additional heat impacts associated with storms. That this was a study focused on the Caribbean, the small island developing states in the Caribbean, and we did that in part because the mainland, and even like the larger islands like Jamaica and Cuba and Hispaniola and whatnot, they can be, the heat signal can be impacted by the big landmass in the United States. Obviously things are warmer over the land. So we sort of so again, our goal was to look at the patterns and see if there is patterns that are just unique to these storms, both in space and in time. And so we chose to look at the small island developing states that were sort of outside of the influence of the large landmass of the United States. But in Puerto Rico, obviously the case example is hurricanes Maria and Irma in 2017, and in Puerto Rico, power was out in some locations for up to 11 months. 11 months. And honestly, I was there not too long ago, this year actually, and the grid is still suffering from the aftermath. So yeah, these impacts, they linger, right? And then they get compounded by subsequent events that come on. I guess the only other thing that I would say is, and I mentioned this before, it is just that, sort of where, impact science is at the moment is it's thinking pretty deeply about, how the co-occurrence, the compound and complex nature of these hazards. And it's the case where you can have a hurricane strike Texas, for example, and that divert resources from FEMA, for example, that 2 weeks later, when a hurricane strikes Florida, there's less of an ability to respond. So you can have these compound hazards that are both spatially coherent, like they strike, like Hurricane Irma and Maria and back-to-back hurricanes in Puerto Rico, or you can have hurricanes that strike one area that decimate or reduce the capacity to respond, that then affects the response in another area. And then you can, of course, have compound hazards that are overlaying different forms of hazards like heat and hurricanes and whatnot. So it's quite an exciting field just to think about. Exciting might not be the right word. It's tragic too, but it's important to think about how these different events sort of overlap, and of course doing that within the context of people and the ability to actually deal with both the response and the preparation for the next one. So the social condition is absolutely important as well.